Okay, we're looking at numbers 4, 5, and 6 on the review in this video. So number 4 says what lump sum should be deposited into an account that will earn 3.75% compounded monthly in order to grow to be $300,000 for your retirement in 20 years. Now this one sounds a little different than the others because it doesn't give us a starting amount, it gives us an ending amount of money. So this amount is in the future. So this is our future value, or what we're calling S. Okay, so notice it asks us what lump sum. So when we see that, what that tells us is that we need the principal. So we need P. So if we go to our formula chart, and we did see the word compound, so we're going to be under compound interest. We didn't see continuous, so this one's out. So out of these two, notice the bottom one is if you know the future value and need the principal. So anytime you see that lump sum, it's going to be this bottom formula. So let me go ahead and write that one down. P equals S over 1 plus I to the n. All right, so S is going to be our future value of 300,000. Remember, I is going to be R over M. So R is our rate, so 0.0375. We're compounding monthly, so M is 12. And I'm going to leave that as a fraction. And then remember, N is M times T. So we're going to compound 12 times a year for 20 years. And that is going to give us 240. All right, so if we put all of this into our formula, we get 300,000 in the numerator, and the denominator 1 plus 0.0375 divided by 12, all raised to a power of 240. All right, so now we've got to get that into our calculator. So I'll try to put this where we can see it. I'm going to enter the 300,000 first, divided by parenthesis 1 plus 0.0375 divided by 12. Oops, that was a minus. Let me go back and change that. All right, divided by 12. We're going to close the parentheses and raise it to the power of 240. Now remember, we're looking for present value. So we want something that will grow to be 300,000. So we're expecting something less than 300,000. And we get $141,875, and it's 784. So I'm just going to round that to 78 cents. All right, and that would be the lump sum that we would need to deposit. All right, then we move on to 5 and 6. These are asking us for annual percentage yield. So I'm going to get the formula chart back out for a second. We have two formulas for annual percentage yield. If we're doing continuous compounding, we use this one. All other times, we will use this one. All right, so for number 5, we're asked which is better, 5.2% compounded continuously or 4.3% compounded quarterly. Now keep in mind this is a loan, so interest is extra money you have to pay. So for a loan, lower is better. So for a loan, we always want the lower. If it's an investment, you want the interest rate to be high because that's money that's getting paid to you. So if it's an investment, we will pick the higher. All right, so for number 4, I like to get these separated. We have 4.2% compounded continuously. So as soon as we see that word continuously, we know we're using the formula that has E in it. So just like always, we write the formula down first. The only thing to plug in is the interest rate. I do have to make it a decimal. So 0.042 minus 1. All right, so I go to my calculator. I find the E, so second ln. Notice it opens parentheses for you. So we're going to put 0.042. We're going to close those parentheses and then minus the 1. Now here's the trick to these problems. We want to be careful about rounding too much because we haven't changed it to a percent yet. So generally we keep 4 places, 1, 2, 3, 4. So the 8's going to be my last place, but notice the number next to it is 5 or bigger, so I'm going to round that up to a 9. So 0, 4, 2, 9. Okay, then when I change that to a percent, I get 4.29%. These answers should always be a little higher than what you started with. We started with 4.2, so that seems reasonable. Now for my second one, I'm asked to do 4.3%, but I'm compounding quarterly. I'm not doing continuous, so I want my other formula, which is going to be 1 plus I raised to the m minus 1. Now remember that I is r over m, so that'll be 0.043, and quarterly means 4 times, so that's going to be a 4. All right, so here's your m and here's your r. So when I plug that in, parenthesis 1 plus 0.043 divided by 4. Notice in most of our formulas this is an n, but when we're doing APY it's going to be an m, so it's going to be 4 as well. And we're going to plug all that into our calculator. Alright, so we'll do parenthesis 1 plus 0.043 divided by 12. We're going to close our parentheses, raise it to the 4th power, and then minus 1. Once again, we need 4 decimal places. 0, 1, 4, 4. The next number is a 1, so I don't have to round that up. Just 0, 1, 4, 4. Wait, did I mess something up? Because that doesn't look right. Nope, definitely messed something up. Let's see if I can figure out what I did. Oh, look, I put a 12. All right. That didn't make sense because it was coming out 1 point something percent, and I know it should be 4 point something percent. So I'm going to do second enter. And I'm going to go back and delete, and I'm going to change that to a 4. All right, so I have the wrong m in there, and that looks like a much better number. So 0.043. Now notice next to my 6 is a 9, so I'm going to round that 6 up to a 7, and that's going to become 4.37%. And remember, I am choosing the lower. That would be better for the loan. So I'm going to circle this as the best option. So I'm going to put best option. All right, so for number 6, I'm doing basically the same thing, but it's an investment, so I do want to take the higher value. The first one I'm compounding monthly. Notice it's not continuous. So I'm going to use 1 plus I raised to the m minus 1. So it'll be 1 plus. My I will be my interest rate, 0.051 divided by 12, since I'm compounding monthly. I'm going to raise that to the power of 12 and minus 1. All right, let's see if I can get this in the calculator correctly this time. So parenthesis 1 plus 0.051 divided by 12. Close parenthesis, raised to the 12, minus 1. So 0.0522, next to the 2 is a 0, so I'm going to round down and just have 0.0522. So that would be 5.22%. These should always be a little bigger than the rate that you start with. All right, so that one we did 5.1. This one we're doing 5.2. Semi-annually means twice a year. So for this one, m is going to be 2. I'm not saying anything continuous, so I'm not using the formula with the e. So that'll be 1 plus 0.052. Semi-annually means twice a year, so I put a 2 there. And then I also put a 2 as my exponent. All right, so 1 plus 0.052 divided by 2. raised to the 2 minus 1. I get 0.05267, so that 7's going to round that 6 up, and I'm going to get 0.0527. And that's going to be 5.27%. Now I'm doing an investment, so the higher interest rate is better. So this would be the best option of the two.